Hello everyone, my name is Prateek Tambe and I have more than 5 years of experience in teaching the students preparing for IIT JEE and NEET exam. I have taught in various reputed coaching institutes of India. Today I am going to be taking a very important topic of class 11th physics, that is parallel axis theorem. In rotation chapter, or we popularly call it system of particles chapter, we have moment of inertia. A topic is there. In that we have this subtopic parallel axis theorem. Okay, what is the why parallel axis theorem, or why do we need to learn parallel axis theorem is, suppose I have learned moment of inertia values for some specific bodies about some specific axis, but if you all will be knowing, if I have a body, let us say this, I can rotate it about many infinite type of axes. Suppose I can put axis here and rotate it like this. I can put axis even here, passing through it and rotate it like this. I can put an axis to the center, rotate it like this. I can put a axis here, rotate it like this. I can put axis like this and rotate it like this. I can put center to axis to the center and rotate it like this. So there are infinite ways of rotating a body depending on the axis. So, are we going to learn thousands of formulas of moment of inertia? No. We need to find some way by which, if we know few specific values, with the help of those specific values itself, I will be able to write the moment of inertia of this body about any axis. Okay? There comes in picture parallel axis theorem. Okay. First I am going to explain you what does it say, then I am going to define it. Okay, let's start. Suppose this is a body given to me, and what I know, first of all I should know what I know, and with the help of that what I can write. Okay, what information I know? I should know the moment of inertia of this body about an axis passing through the center of mass of this body. Let us suppose this is a uniform body, and for the sake of assuming I am taking, suppose somewhere here the center of mass of the body is there, and I take a axis passing through the center of mass of the body. Okay, and I know the moment of inertia of this whole system about this axis. If I rotate it about this, I know the moment of inertia. Someone asked me, can you write the moment of inertia about an axis from here, and I want to rotate it like this? I will say yes, definitely. You just need to tell me the mass of this body and what is the distance between this axis and this new axis about which you are interested in finding the moment of inertia. So he said that, let us say the distance is CD, and the mass of this whole body is the mass of this whole body is m. So what I will say is, if the moment of inertia about this axis, which is ICM, is, let us say, ICM, the moment of inertia passing through the center of mass axis is ICM, then the moment of inertia about this new axis about which I want to rotate this body will be ICM plus mass of this body into distance, perpendicular distance, whole square. Did you get it? What I know is ICM. I want to write the moment of inertia about this. So what I should know is, how I will write ICM plus mass of this body into this perpendicular distance whole square. This will simply give me the moment of inertia about this new axis. How easy it is. You can see, suppose someone asks me, okay, you know moment of inertia about this, can you write the moment of inertia about an axis? So I am interested in putting an axis passing from here, and I want to rotate this body like this. I'll say yes, you just need to tell me this distance between these two axes and the mass of this body. I'll say this is moment of inertia ICM. This new moment of inertia will be ICM plus md square. Simple. This made our life very easy. Okay, so I will define it now. If we know the moment of inertia, we know moment of inertia of a system of particle passing through, about an axis, moment of inertia of system of particle about an axis passing through center of mass system then the moment of inertia about an axis parallel to center of mass axis and at distance d from it can be written as I is equal to ICM plus MD square. I'll define. Okay, let us say I take this body. It can be of any random shape. Okay, I know moment of inertia about an axis. Let us say this is passing through the center of mass of the body. This is center of mass C, and I know the moment of inertia about this axis ICM. Now I just need I want to write the moment of inertia about this of the same body about an axis. It is not necessary that the axis has to be within the body. It can be outside the body. The only condition is it has to be parallel to the axis passing to the center of mass of the body. And I should know the distance between these two. So I can write the moment of inertia about this I. This I will be equal to ICM plus, let us say m is the mass of the body. This body has mass m. Okay, so m is mass of body. Body being a system of particles. A lot of small particles will come together to form this body. ICM is moment of inertia. I am writing in short form. MY stands for moment of inertia of body about axis passing through center of mass. COM stands for center of mass of system. Okay, and D is the shortest distance between the two axes. Shortest distance between the axis. Okay, shortest distance between the new axis and center of mass axis. I hope it is clear. I have explained you very well with the help of this water bottle. Okay, it is not necessary that this axis has to pass within the body. This can be anywhere outside. We just need the distance. Okay, so that is it. With the help of this, we can write the moment of inertia about, and if you know, we generally learn the moment of inertia of the various shapes of the body about the axis passing through the center of mass itself. Okay, let's try to apply this theorem and what we can do with the help of this. Okay, yeah, one more important point which is there for this theorem is this can be applied to both planar and 3D bodies, 2D and 3D bodies. So an important point that we can write for this theorem is note. This theorem is applicable to both 2D and 3D objects. Okay, let's take our first question. Suppose this is a rod of uniform mass per unit length. The total mass of the rod is m, and L is the length of rod. Mass of rod is m, length of rod is L. Do I know the moment of inertia about this? Okay, let us say someone asked me to write the moment of inertia about this axis I. Okay, find the value of I about axis shown. Here is the axis. How do we solve this question? Many of you would have learned this value ml square by 3, but let us try to find it by using parallel axis theorem. What I need to remember now is the moment of inertia of this rod about the center of mass axis. So let us try to solve it. Do I know the moment of inertia of this rod about the axis passing through its center of mass? Yes. The value of ICM will be equal to m L square by 12. This we have to remember at least this value. Now I am interested in writing the moment of inertia about this axis I. If the whole length of the rod is L, can I say the distance between these two axes will be equal to L by 2? Yes. So what I can say by parallel axis theorem, the value of I will be equal to ICM plus mass of this rod into d square. So this will become I is equal to ICM plus mass of the rod. The value of distance between these two axes is L by 2. So this will become L by 2 whole square. As simple as that. The value of ICM I will put here. So this will become ml square by 12 plus ml square by 4. So here on taking LCM, what I will get is ml square plus 3ml square. 3ml square. So overall this will become 4ml square by 12. So this will become 4ml square by 12. This will become ml square by 3. And that is what we learn. But if we do not remember also, the value, minimum value that we have to remember is the moment of inertia of this rod about center of mass. So this has made our work very easy. Similarly, you can find the moment of inertia about any of the axes about which you are interested in rotating this rod. Let us try one more thing in this same question. The same question, I hope you have written this. If the axis is not here, I am interested in rotating the same rod about an axis which is from here and at a distance L by 4 from the corner. Okay, this is the axis about which I am interested in rotating this rod. Can you find the moment of inertia of this rod about this axis? You will say yes. So you have taught me parallel axis theorem. I will apply that because I know the moment of inertia of this rod about an axis passing through its center of mass. I know this distance also because this is L by 4, this whole will be L by 2. The remaining will also be L by 4. So this is very easy to find out. Try yourself. Okay. So again, this is ICM, which is ml square by 12. I have to find the moment of inertia about this axis. Let us say this is I, and we know this distance will be equal to L by 4. Because this is L by 4, this will also be L by 4. Okay? So this I will have a value ml square by 12 plus m into L by 4 whole square. Very simple, right? Okay, so this will become ml square by 12 plus ml square by 16. This will become, the LCM will come as 48. So 12 4s are 48 plus 16 3s are 48 times of ml square. So this will become 7 ml square by 48. Very easy. Let us see some more applications of the same theorem. identical spheres of mass m, radius r each are as shown in figure. Find the moment of inertia of system about axis shown. Okay, how can I approach this question? First we need to understand. See, parallel axis theorem application is there. First we need to understand. How we will understand? I am interested in rotating this whole system about this axis. So two spheres are rotating like this. Okay. So I need to find the moment of inertia of this. So it will look like the moment of inertia of this about this axis plus moment of inertia of this about this axis. But we don't know the moment of inertia directly, right? So here comes in picture parallel axis theorem. Do we know the moment of inertia about an axis passing through the center of mass of this sphere? Yes. We remember the value 2 by 5 mr square. So this axis looks parallel to that axis passing through the center of mass of the system. So I can easily write the moment of inertia about this axis by ICM plus m into this distance whole square. In the same way, this system also looks identical to this. So either I can again apply parallel axis theorem, but instead of that, if I am able to see that, I will simply multiply the moment of inertia of 1 about this into 2. Okay, so let's try to do it that way. So I will write the moment of inertia of one sphere about this axis. I know this ICM, and this distance is equal to r, right? So the value of I will become ICM plus m times of r square. Simple as that, right? Small. What is the value of ICM? It is 2 by 5 m r square plus m r square. So this will become 7 m r square by 5. But this is moment of inertia of only one sphere about this axis, right? But I need the moment of inertia of two spheres about this axis, so I will simply multiply it by 2. So the total moment of inertia will be equal to 2 times of 7 by 5 mr square. So this will become 14 by 5 mr square. Okay, so I hope you understood parallel axis theorem. Next is perpendicular axis theorem that we will see in the next class. Thank you.